So hello guys, welcome to the programming knowledge. So today we'll be learning about linked list, the basics of linked list, like what is the meaning of linked list, how do you apply linked list, what is the difference between arrays and linked list, and why are we using linked list. So before we begin learning about linked list, I would like to give you a little representation of what linked list looks like. Okay, so for example, assume an array. So how do you operate on arrays? So in array, usually you have these type of boxes, what you see in the diagram, like all the elements are linearly connected to each other, right? All the elements are linearly connected to each other, and each of these positions contain elements. Like let's say one is here, 2 is here, 4 is here, 3 is here, 5, 6. So this is what an array looks like. Like you first declare an array. Obviously you know how to declare an array, int ar of n, where n is the size of the array. So what the disadvantage of array is basically that you already define the size of the array. And then you cannot extend the size of the array, or you cannot either smaller the size of array remains exact of the same size. So that is the main disadvantage of disadvantage of arrays. So to encounter this problem, what we basically do is we use linked list. So what linked list looks like, so let me show you an example. So in linked list we have 2 fields in each of the elements. Okay, this is one element, right? This is another element, and let's say we have for now 3 elements in our linked list, right? Each of the elements have 2 data parts, and also you should be knowing that each of these elements will have an address. So let's say that our first element has an address 100, second element has an address 200, and third element has an address 300, right? So and now let's our first element have element as 1, second element has element 2, and third element has element 3. And what we have over here is that these elements are connected to each other in this way. So as you can see, first element is connected to second element, second is connected to third element. So now you would argue, how are these elements connected? So the solution to this problem is that this second part contains address of the second node. So in this case, first element is pointing to the second element, and the address of second element is, as you can see, it's 200. Address of second element is 200. So this 200 is being stored in the address part of the first element. So now let's put 200 over here, 200, and also this 300, this 200, this second element is connected to the third element, and this 200 is stored in this. So now let's put 300 over here, and looking at the third element, what we have over here is that there is no element next to it. We have only 3 elements, so we store null in this case. So it is pointing to nowhere. So this is the basic representation of linked list, and the beauty of linked list is you can increase the element size in linked list dynamically. So that is the main advantage of this. And also, if you look into this figure, what you would observe that in order to access or traverse this array, we only need address of the first element. If we have the address of the first element, we can traverse through each of the elements one by one, right? So now let's get to the coding part of it, and then yeah, let's do some coding. Okay, so here I have my desktop window, and let me just write a brief code. Okay, so now the main question is, how are you going to store this element and address of this structure, address of this node? So the answer to this problem is, we'll be using a structure of elements, right? A structure of, so this is an entire structure, this is our second structure, and this is our third structure. So what we do is, we'll define a structure first, struct, let's call it node. And so we have defined a structure. So this structure has two parts it has. The first one is storing the data, and second one is storing an address of another node. So how do we write in code is int data. So this will basically store the data, int data. So this is our data, right? This is our data. And now let's define and node star link. So this is the most important step. So this is the second part, which stores this link stores the address of the second node, and that is why we use node star. So this is node, so it is a pointer to a node, to the next node. So that is how we write it. And one more thing I want to show to you is, we need another element called head to traverse all the elements. So what, we'll have one more node star which will look like this way. So this will be your head, this will be called head. What this will do is, it will basically point to the first element, and it will store only the address of the first element. So let this store 100. So this is of type, these both have same types. So this is only storing the address part of the first node and not storing any data, because this is our first element and this is how they're connected, right? So now let's define a node star head. So if you notice, I've done this global declaration, which is fine. So this line node star head corresponds to this element, right? And initially, when there are no elements in our list, what we have is head is equal to null. So head is pointing to nowhere. So initially we have nothing in our head. So this is what our element will look like. So this is our head initially, and let's call it head. And initially it has nothing in it. It contains nothing, null. Head is equal to null. So we have defined it over here. Head is equal to null. So head contains nothing right now. And now what we want to do is, let's insert our first element. Insert our first element. So how do you do that? In order to insert an element, know, right? Node basically has two parts. Okay, so let's do it again. So first part and the second part. The first part stores the data, so let's store some data. Okay, the first process is to just create a node. So let's create a node. So if you look at the left side, how we create a node is we use this command called node star space, and let's call it something like, let's call it first node. Let's call it first node. So node star first node is equal to new node, because we are creating a new node. So this is the main command. So this is important, you need to know this command to create a new node. And now the first thing what we do is, obviously let's say we are inserting 1. So in the data part of this, you will insert 1, which is this way. This element contains 1, right? So how you do this over here? So you use this command called first first node and then minus arrow of data. So let's put data over here, data is equal to, let's say it contains 1. So this is the command to initialize this, right? And also we know head is pointing to null. So now that we have done this, and since this is the last element, right? So in this case we have only one element and this is the last element. So what we have to do is initialize this to null, right? Initialize this to null so that we know that there are only one element in our list. So how do we do that? In a similar way, first first node of, here we use link now. First node of link is equal to null. So very simple. So now we have done this. Now the only part remaining is connecting this node to this node. Let's say our node has an address of, let's say 500, right? And now what you have to do is, instead of this null, we have to store 500. Very simple. So there will be no null right now. Let's erase this. There is no null, but we'll store 500 in this so that we are connected in this way. So how do you do that? You simply say head is equal to first head is equal to first node, which makes sense. So head is pointing to the first node, so head will contain the address of the second node because head is of type pointer. So head is equal to first node, and now let's print it, which is cout first node is just first of first node is first node of data. So this should print 1. So now let's try running this program. Okay, as you can see, I can see first node is equal to 1 printed on my device, right? So this is working, right? So this is fine. And now what we are going to do is we are going to extend this list, okay? So now let's erase this stuff, extend this list, add one more element at the beginning, or let's add one more element at the end of the list. or let's add one more element to the beginning of the list so you have an understanding. So in that case, what you're supposed to do is we'll create okay, so we're supposed to create one more node in between head and the first node. So this will be our second node, right? And let's say this will have an address of like wait of let's say 1000. So what we now need to do is point our head to this variable and head points to this variable, so that now this will not contain 500 anymore, but this head will be pointing to our first element, which will be 1000, which makes sense. And let's say this will store 2, right? And now this needs to store 500 because this is our third element and this is how it will be. So you can see head is pointing to this, this is pointing to this. So how do we do that? It's very simple. What we do is let's create a second node. Okay, let's call this one second node for reference. Second node. Okay, this is a second node. So we'll just copy this line. So as you can see, I've created the second node over here. Let's rename this to second node. Second node. And also you know that second node of data is equal to obviously 2, you've seen it. And now what you need to do is second node of link is equal to head of link, because initially head is pointing to this element. Initially we know head is pointing to this element, head is pointing to the third element, so head of link is equal to this element. So now we need to connect this. So what we do is second node of link is equal to head of link, which makes sense. And so what we have done is we have connected this till now. We have connected this. So when we write this command, second node of data is equal to 2, second node of data is done as 2, second node of link is equal to head of link. So initially we have this connection, right? Head of link is equal to this. So now we connected this way. So second node of link is equal to head of link, and now we need to connect head to the second node. Connect head to the second node. How do you do that? Very simple. We write head is equal to second node now. And so now let's just try to print cout. So now let's try to print both the elements, first and the second element. How do you do that? So for printing first element, let's put cout. Okay, now let's print first element is equal to, so we all know what's first element. First element is First element is our first, first node of data, which is fine. And let's print similarly second node, and let me put second over here. And now let's run this. So you can see the output. This is our first element and this is the second element. So our program is working. So this is it for this lecture, and this is the basic understanding of how linked list works. And in later on the videos we'll be seeing how to insert an element at the beginning of the linked list, how to insert at nth position of a linked list, how to delete an element in the linked list. We'll all be seeing in the next lectures. So thank you everyone for watching.